Hey guys. So talking about erosion, something I like to think about is the beach, where sand comes from. I don't know if you've ever experienced this, but I went to the beach in New Jersey when I was a kid a lot. And every year I'd go to the same spot, but it would look completely different. One year there'd be 20 meters of sand until the ocean. The next time there'd be 50 meters of sand. So I always wondered, why does the beach always look so much different? Why does it change a lot here but doesn't change in other locations? Why is there more or less sand? Why is there sand at the beach? And we're going to address a lot of that. So first off, waves are able to push and pull. And waves don't just come straight into the shore. They usually come in at an angle. That angle decides whether the sand is going to get pushed to one side or pulled from one side. And that really is what shapes our beaches. We build these things called jetties and groins to stop that from happening, or attempt to stop that from happening. But there's not much we can do because the beach and the ocean is just so powerful and it's so massive that all of our actions that we try to take, it just kind of like the beach just does what it wants, essentially. So speaking of that, we call this wave and ocean currents, it's called a longshore drift. So a longshore drift means that waves don't just come in at the beach and away from the beach. They run along the beach. They come in at an angle and push and pull different sediments from different locations. So here's an image of Cape Cod. Cape Cod is off the coast of Massachusetts. And this is actually what we call, it used to be, or I mean, it partially is a glacial moraine, meaning that a glacier about 20,000 years ago, up to 11,000 years ago, pushed down during the Ice Age, and it made it this far down, huge continental ice sheet. Made it that far down, and it scraped and it pushed all these rocks and sediments, and then it began to melt, which we call a retreat. As that glacier melted back north, it left this huge area. What it didn't do was place the sediments in this hook shape. What did that was the longshore drift. The ocean waves, you can kind of see them here. These ocean waves come in at an angle and just push and push. So we used to have a big mound here, we assume, and that got pushed and kind of snaked around, and all those sediments got laid out there, which now we call Cape Cod. All right? So we think of beaches as being these places that are stable and they're there every year, but when we look at beaches over tens of thousands of years, not only including the fact that the ocean levels rise and sink, the beaches are always changing. Always. We just live some short lives compared to the age of the earth. So, to talk about predicting the longshore drift, we can look at an image like this. This is called a jetty. So a jetty is where like a river or a stream flows into the ocean, and we build these barriers there. They're just huge areas where we lay a bunch of rocks, like giant boulders. Sorry, my kitty's playing with his toy, if you hear a little dingle in the background. But which way is the longshore drift pushing, right? So is it going towards the left or is it going towards the right? What we look at is where there's a buildup. So if you imagine my hand as being a wave and I push and I push and I push, I'm pushing all of this sand up to this jetty here, while this is going to be pulling away from this, right? So this is a buildup and this is an erosion, right? So deposition over here and erosion over here. Sediments are being dropped there, sediments are being moved here. And you can see that it really hooks out from underneath that. You can also see these groins here. These groins have a buildup of sediment on the right side and erosion on the left side. So there's deposition on the right side of this, erosion on the left side, deposition on the right side, erosion on the left. Okay? So this is what you could imagine longshore drift is. It's just ocean waves that come in at an angle and kind of push and push and push and grab that sediment and slowly move it down the beach. And then we end up with things like this, where there's erosion on one side and there's deposition or buildup on the other side of these jetties or of these groins. Again, We're just going to transport sediment. And if we transport sediment over a long period of time, we can see we've got this little headland here. And as time goes on, the sediments end up building up on the outside of that, right? And then it starts to get pushed over, and it forms these little areas where they're like ponds almost, where they're cut off from the ocean, thanks to longshore drift. All right? So, just some features that you'll see from this are this is called a spit, and a spit is just kind of like this little section where we have this like hook from that longshore drift. But the most important thing to note are barrier islands formed from this. So you can see this line here. This is partially, so one area of it is called Fire Island. I don't know if you've heard of it, but it's just a beach. It's a very, very long beach off the coast of Long Island. And what we used to have was a huge buildup of sediments here, but then the longshore drift kind of pushed all these sediments into this one long line, and that is what causes a barrier island to form. A great example of a barrier island are the Outer Banks of North Carolina as well. I believe I have a satellite image of that. Yep. So this is the Outer Banks off the coast of North and South Carolina, and it's just this long area of pretty much a giant sandbar. A giant sandbar that's above water. It's very, very unstable. It is moving. So something that I would suggest is don't buy a house on a sandbar, because thousands of years ago that sandbar didn't exist. And if it did, it was probably in a different location, because these things really do kind of just go wherever the waves push them, thanks to longshore drift. Okay, we're almost set. So again, if I were to ask you to predict which way you think these waves are going to be, or the longshore drift is pushing, I would say to the right, because we have a buildup of sediments here, and then we have a lot of erosion, cutaway of sediments over here. So whatever used to be here, maybe the beach was out to here, but that got moved to wherever the next jetty or the next groin is down the beach. All right. Hopefully this makes sense. Nice short video. I'm trying to keep them shorter so I don't just ramble on. Here's just an image to show you that humans really try to stop the sand from moving, but it just makes your beaches look a little silly, and doesn't work as well as you'd think. But once you start building them, you can't stop. All right, so longshore drift is going to be causing erosion on our beaches, and they form barrier islands, spits, and these things called sandbars. Sandbars are essentially barrier islands that are underwater, and they're just off the coast, and you can go out into the water, it drops off, and then you'll see it rises back up in some spots. Don't go out looking for sandbars when you're at the beach. Also be careful of the undertow. It can really drag you out. If you get caught in an undertow, which is just a current that pulls you out, because all of the waves end up building up and then funneling into one spot and pull you out. If you get pulled into that, don't swim back towards the shore. Swim along the shore until you escape that general that current, and then swim back towards the shore. All right, have a good one.